Sorry about that. Number 13. Jonah is thinking of a 2-digit number. It is a multiple of 6 and 12. It is a factor of 108. The sum of its digits is 9. What number is Jonah thinking of? Okay. He's thinking of a 2-digit number. It is a multiple of 6 and 12. So that means if I go 6, 12, 18, and I keep counting, it's going to end up there. But you know what the cool thing is about 6 and 12? All the multiples of 12 are also multiples of 6. 48, 60. I'm going to stop there because I'm going into my next problem. Okay. It is a multiple of 6. It is a factor of 108. So if I multiply one of these numbers times something, I'm going to get 108. The sum of its digits is 9. Let's see here. The sum of its digits is 9. Well, this is 3. This is 6. So that means if I add those two up, this is 9. Could it be this? Maybe. 4 plus 8, that's 12. Well, this is 6. Could it be 36? I don't know. Let's check it out. Let's do some guess and check. So 36. I want an 8 in my ones place. What could I multiply by? Let's try 3. You get 18. It works. What number is Jonah thinking of? He's thinking of 36. Okay, number 14 I'm going to do with you. In a bag of 100 balloons, 12 are red and 13 are green. What fraction of the balloons in the bag are not red or green? So if we take red and green and we add them together, we get 25. So there's 100 balloons, and it says which ones are not red and green. Well, 25 of them are red and green. So how many are not red and green? Hopefully you can do this in your head if you think of quarters. But if you can't, 75. 75 hundredths are not red or green. Okay, let's look at number 15. Morse code is a way to transmit text using a series of dots and dashes. The Morse code for add is shown. What fraction of the shapes are dots in the Morse code for add? So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 total. That's our denominator. And it says what fraction of the shapes are dots? 1, 2, 3, 4, 5. So 5/8 are dots. Number 16. Diego compared the differences for 10 tenths minus 1 tenth and 100 hundredths minus 10 hundredths. He said the differences both equal 9 tenths. Let's see if he's correct. So 10 tenths minus 1 tenth equals 9 tenths. Okay, and then we've got 100 hundredths minus 10 hundredths. Well, that equals 90 hundredths. Oh, do you see something here? We talked about this the other week. So we've got 9 tenths. Does that equal 90 hundredths? Does that equal? Yeah, it does. It's just like when we add those decimals. We can put a 0 at the end as long as we do it on top and bottom. So yes, Diego is correct. And why is he correct? Because 9 tenths is, here's a word you never think you see again, equivalent 2 90 hundredths. Okay. And let me do number 17 with you yet. 5/8 of Marie's marbles are red and 2/8 are blue. The rest of the marbles are white. Draw a model to represent Marie's marbles. Write and solve the equations. So we've got 5/8 are red, 2/8 are blue, and we need to know how many white ones there are. So I can do it this way. So 5 plus 2 is 7. So 7/8 is the blue and red. So 7/8. Wait, oh, I should have wrote that different. Let me squeeze them in. 8/8. Now, where did I get 8/8 from? Because that's the total number of marbles is going to equal 1 whole minus 7/8, which is the red and blue, equals 1/8. So here's our equations to find the fractions. We're not going to worry about drawing a model. So 1/8 is white. Okay? All right, you are doing the rest of them on your own.